If it isn't a piece of candy stuck in Junior's throat. X-ray gives the doctor the inside information. And now he can assure Mother that the candy will soon dissolve and Junior will be as good as ever. So this is what Mrs. Brown saw. Inside information on Junior's pockets. Yes, X-ray is a wonderful invention. The X-ray is produced in a special kind of vacuum tube. It is a form of vibration. Sound is vibration too. When a sound wave vibrates too fast, we have trouble in distinguishing it. Or when it vibrates too slowly, like the deepest bass notes, it approaches the limit of our hearing and sounds like a rumble. Did you ever see one of these high-pitched dog whistles? Well, did you ever hear one? There was a sound. The dog heard it, although the sound wave was vibrating too fast for human hearing. Certain types of waves are visible to our eyes, and so we call them light. But the X-ray vibrates 8,000 times as fast as ordinary light, far beyond our range of vision. We can't see it at all. However, we can take a picture of the image cast by the X-ray on a specially prepared film or plate. Or we can see the image through a fluorescent screen. One of its applications is by police departments to find out what's inside the suspicious-looking packages. This innocent alarm clock might have been a bomb. X-ray inspection makes sure of safety here, just as it does in the field of medicine. And today, in the great plants where military planes and passenger liners are built, safety in their construction is assured by the use of X-ray. Giant automatic X-ray cameras take photographs of all the vital parts. In these machines, the parts move in under the X-ray tube, where a 1-ton lead hood comes down to cover them during exposure. Timing and intensity of the X-ray exposure are automatically controlled. In the finished films, the grain of the materials is examined to determine the strength of the part and to find the slightest defect. These precautions are taken in order that America may build a great and powerful air fleet, and equally important, for the safety of the men who fly. X-ray has given us increased safety in the air. But more of us are concerned with safety on the streets and highways. The modern automobile has many safety features, one of the most important being good brakes. Here too, X-ray can give us interesting inside information. An X-ray photograph shows that this brake shoe has worn evenly along the full length of the lining. Here's an X-ray of a shoe from another type of brake. This one has worn thinner at one end than at the other. Let's look at the brake from which it came. In this brake, the shoes are anchored on a fixed pivot, but the heat of brake application expands the metal of the shoes. This expansion causes varying pressures of the shoes against the drum, resulting in uneven wear of lining. In the first brake, where the wear was uniform, there is a movable linkage which allows the shoe to press evenly against the drum. As the brake heats, the movable links compensate for expansion, smoothly maintaining an even pressure at all times along the full length of the lining. And so, today's most modern automobile is built with brakes that give us more miles of effective service, assuring the driver of greater safety and economy. Safe, smooth stops, and many more of them, are the result of engineering research. When they designed this mechanism, the engineers hit upon a simple device. They copied nature. The ankle acts as a pivot to distribute the pressure of our weight evenly between the toe and the heel. For inside information on ankle action, let's call upon one of the newest and most startling developments of science, X-ray motion pictures. For the first time on a theater screen, we are about to see action pictures photographed with special equipment that utilizes the wonderful X-rays. Inside information on ankle action. X-ray motion pictures show that as we step down on the ball of the foot, the ankle acts as a movable pivot, allowing us to lower the heel and even out the pressure. X-ray motion pictures of such simple action represent an important forward step to science and engineering. These remarkable pictures allow us to see the same action in nature that has been engineered into the modern automobile brake, a movable link that distributes pressure evenly. And so it's the linkage in the ankle that gives us smooth, even pressure, whether it's driving the modern motor car or dancing the graceful measures of a lilting ballet.